Today I'll use LabVIEW 8.2 to illustrate amplitude modulation. I'll be able to quickly and easily create a program capable of modulating a message frequency with a carrier, and I'll be able to examine the time domain and power spectrum of the result. On the left, I have the gray window, which is the front panel where the user interface is designed. On the right, I have the block diagram where the graphical code is actually placed for my program. To begin with, in amplitude modulation, there are two sinusoids we'll need to create. We use the basic function generator VI for both the message and the carrier. This particular VI outputs a signal, the default of which is a sinusoidal signal with various characteristics that we can control, being frequency, amplitude, and phase. For this particular example, we'll only need to control the frequency. To do so, I'll actually need to be able to need to create a control on my front panel. I'll call this one message frequency. Similarly, I will create a frequency control for my carrier frequency. And you see that as I've created those in the block diagram, user controls have appeared corresponding to these icons on the front panel. Similarly, I'll need to create a numeric indicator which is responsible for controlling the carrier amplitude. This will actually be added to the message sinusoid in order to offset it appropriately. Now that I've placed this numeric indicator on my front panel, you can see that an indicator appears corresponding to it on my block diagram. In order to add this to the message, I simply go to the numeric palette, select the add VI, and I wire up X to the sinusoid and Y to the carrier amplitude constant. Now this offset signal just needs to be multiplied by the carrier signal. And again, I'll go back to my numeric palette and select the multiply VI, the two inputs to which are the message and the carrier. Now that I've successfully modulated my message and my carrier signal together, I'll want to graphically display these in my front panel. In order to do so, I right-click on my front panel and go to the Graph Indicators palette where I select Waveform Graph. I place this graph on my front panel and you see that an icon appears corresponding to it on my block diagram. Now for the sake of illustrating the concept of amplitude modulation, I'll go ahead and represent multiple signals on this graph. I'll show both the modulated signal and the original message. I'll wire up the output of these merged signals to the waveform graph, and before running it, I'll set my carrier frequency to 100 Hz. When I run it, you can see how it displays both the message, the original message, and the modulated signals at the same time, and you can see how the message follows the shape of the modulated signal. Now, another important concept in amplitude modulation is the power spectrum analysis of the AM signal. So in order to perform this advanced mathematical calculation, I simply place the FFT power spectrum VI on the block diagram. One of the inputs is the time signal, which I will simply wire up to my modulated output. And again, I'll want to graphically display this on my front panel, so I'll go back to the front panel and place another graph. I'll go ahead and expand this slightly so we can see more. And I wire the corresponding icon to the output of the power spectrum analysis. And before running it, I'll provide a carrier amplitude of, say, 3. And when I run it, you can now see the frequency spike around 100 Hz, and you can also see how the relationship has changed between the message frequency and the carrier frequency. Now, if I want to change these parameters on the fly, I can actually continuously run LabVIEW, and I can actually modify both the message frequency, the carrier amplitude, or perhaps the carrier frequency. If I move it to, say, 300 Hz, you can watch and see how the power spectrum analysis moves the frequency spike to center around 300 Hz. In a matter of moments, I've created a program which demonstrates a amplitude modulated communication scheme. I haven't written a single line of code. I've programmed everything graphically, and I'm able to control all of my parameters on the fly without modifying or changing my code in any way. These VIs used in conjunction with various other VIs are capable of demonstrating very advanced communications concepts. This particular example only begins to tap into the power